Hello all, this is Mr. G, and in this video we're going to do a select number of problems from our review on simplifying complex numbers. So let's not waste any time, let's jump right in. So we're going to start with number 7. It says simplify each expression, and we have to simplify I to the 7th times I to the 3rd times I to the 3rd. Now there's not just one way to do this. What I would personally do is I would rewrite this expression as a single I to a power. We just have to figure out what that power is. And whenever we're multiplying expressions with common bases, we add the exponent. So essentially we do 7 plus 3 plus 3. Actually, let me just write that out. We do 7 plus 3, add the powers. 7 and 3 is 10, and 3 more is 13. So we get I to the 13th. But we cannot leave our answer like that. We never leave a power of I in our final answer. We have to simplify it. So to simplify powers of I, we want to look for the biggest multiple of 4 that is still lower than 13. So that's like 4, 8, 12. So we can make an I to the 12th times, let's see, 12 plus what gets us to 13? That's just 1. So it's I to the 1. And then we simplify from there. So I to the 12th, since 12 is a multiple of 4, we know that's going to be 1 times I to the first is just I. So we end up with I as our final answer. And we check it, and that's what we have on the answer key. Very good. All right, number 14, let's take a look. Find all solutions to the following equation. So here we've got one equation, it's x squared plus 49 equals 0. Now there's a couple different ways we could do this. We could try and use the quadratic formula with like an a value of 1, a b value of 0, and a c value of 49. That'd be one way to do it. But I think since there's no b value here, there's just an x squared. There's no x squared and an x to the 1. We can just get x by itself. Let's just take 49 away from both sides. That gives us x squared equals negative 49. Let's write that a little bit better. Equals negative 49. And then to get rid of that power of 2, we just take the square root of both sides. And we get x equals plus or minus, the square root of negative 49. We can split that up into 49 times negative 1. And then what will that become? Let's think. So that becomes plus or minus, the square root of 49 is just 7, and the square root of negative 1 is I. So we're going to write that as, let's see, let's put it here. So x equals 7i, and x equals negative 7i. That's how we're going to write our answer, and let's see if that's what we got up there. Well, we got one of them correct, negative 7i and positive 7i. It's kind of stupid. I have this down there, so we can't check it without my face covering it. Is that what we got? 7i and negative 7i. Okay, good, good, good. Now let's take a look at number 16. Select all appropriate cells in the table below where the product, that's an important word, product of the two numbers is a real number. Okay, so we're looking for real numbers here, and we're looking for where the product of two numbers becomes a real number. So product means multiply. All right, so we're going to be multiplying here. Okay, so first thing I guess we could just like start with the 5 and then check it against every single one and see what it's going to be, see what gives it a real number, and then just sort of go do the next one and the next one. So let's do that, I guess. That might not be the fastest way to do it, but it'll work. All right, so this one, that would be 5 times negative 2. Well, 5 times negative 2, that's just a negative 10. That's definitely a real number, so we can check this one off. That one's a real number. And then 5 times the 11 minus 7i, there we would have to distribute. Tell you what, let me show my work down here. I guess, I don't like that. There we go, that'll look better. Where was I? So it's 5 times 11 minus 7i. We distribute. 5 times 11 is 55. And 5 times negative 7i is negative 35i. And that's as far as we can go. And there's still an I in our answer, which means it's not real, so we do not choose that cell because we're looking for real numbers. Now we're going to try the 5 and the 11 plus 7i. Some of you might be able to predict this answer already. I'm going to show all my work, though, in case anyone needs to see it. Distribute. 5 times 11 is 55, plus 5 times 7i is 35i. And that's as far as we can go. There's no more like terms to combine or any powers of I to simplify, and there's still an I there, so that's not a real number, so we do not pick that cell. All right, next up we've got 6i and the negative 2. We're testing that one. So 6i times negative 2, well, that's going to be negative 12i, which that's a non-real number because there's an I still there, so we don't pick that one. Then we've got the 6i times the 11 minus 7i. And I'll be honest with you, I think we can sort of do this in a faster way than I'm doing it. Let's sort of think about this. So 6i times 11, that's going to have an I in it. So that's going to be something I. And then 6i, oh, this one might actually be good to do all the work for. This would have been bad for me to skip. Okay, I'll show my work. So it's 6i times 11 is 66i. And then 6i times a negative 7 becomes negative 42i squared. Okay, so we could keep going and simplify this. I mean, this I squared is going to turn into a negative 1, so that part's going to be a real number, but there's still going to be this I there, so it's not real. So, I mean, we could write it as our final answer, but we don't need the final answer. We just need real or non-real, and that's non-real, so we do not pick that cell. So now we're moving on to this one, I think we're on? Yeah. So 6i times 11 plus 7i, and again, if you can do this without showing the work, that's a good thing. Let's distribute. So we get 66i plus 42i squared. When we do the 6i times 7i, and again, the I squared becomes a negative 1, so that part becomes a real number, but this I is not going away. It's still there, so it's a non-real number. So far, we've only gotten one real number. Let's hope we can get something more. I mean, it might just be one answer, but let's see. Now let's check the 11 plus 7i times the negative 2. All right. So let's distribute. We're sort of distributing the opposite direction, but that's okay. That becomes negative 22 minus 14i. And there's no more simplifying to do. We still see an I, non-real. Don't pick the cell. Next up, we've got 11 plus 7i. Just moving on to this one. 11 plus 7i times 11 minus 7i. Let's see what happens here. All right, here we got a bunch of distributing to do. Let me move this up so I have some more space. So 11 times 11, that's 121. 11 times negative 7i is negative 77i. Then distribute the 7i to get plus 77i. And distribute that, and we get negative 49i squared. If I'm doing that correct in my head, I think I am. Make that 9 look somewhat better. That's a little bit better. Okay, let me think. Well, these 77s, they just cancel out because negative 77i plus 77i plus 77i, that just goes away. And then here, this I squared becomes a negative 1. So we get 121 plus 49. And I mean, we could simplify that all the way, but we don't actually care what that number is. We care whether it's real or non-real. And at this point, there's no more i's. That means that will be a real number. So let me think. That was the x plus 7i and the x minus, or excuse me, the 11 plus 7i and the 11 minus 7i. And actually, now that we look at it, some of you might have been able to predict that was a real number right off the bat, because what we have here are complex conjugates, two complex numbers where only one sign is different. Okay, last one. Didn't mean to erase that. That's part of the answer. Last one, we're checking this one right here. That's 11 plus 7i times itself, essentially. 11 plus 7i, and then 11 plus 7i. Again, you might be able to skip some of these steps. I'm just showing all the work in case anyone needs it. We get 121 plus 77i plus 77i and plus 49i squared. Do that all correctly? I think so. Okay. What can we simplify? Well, the I squared, that becomes negative 1, which is good. That makes that a real number. Oh, but these i's are not going to cancel out this time. So actually, we can stop right here. Since those i's aren't going anywhere, we know this will not be a real number. So that's our final answer. We only got two real numbers in that whole chart. And I keep accidentally erasing this one. Let's check the answer. Yep, looks good to me. Only those two are selected. Okay, two more to go. Number 17, indicate whether each number is equal to 1, negative 1, or neither by writing it in the appropriate column. Okay, so basically we just have to sort these for I to the 8th, negative 1 times I to the 3rd, I to the 12th times I squared, and 1 minus I times 1 plus I into the appropriate category. So we'll start with I to the 8th. Well, that's just a multiple of 4 as a power, so we know that's going to equal 1. So, okay, we can bring I to the 8th down there. That's the first one, and it equals 1. All right, now we've got negative 1 I to the third. Well, that's negative 1 times I to the third. We know that's negative I. Am I doing that correctly? I don't want to screw this up. Let me do it the long way. So it's I squared times I to the 1. So that becomes negative 1 times I squared is negative 1. Yeah, times I is I. Okay, so I was right. Just double checking it though. And then negative 1 times negative 1 is positive 1. So we get 1 times I, which is I. So that's neither 1 or negative 1. So that's neither. So that one goes right there. Okay. Next up, we've got I to the 12th times I squared. I to the 12th. Actually, I think earlier in this video, we wrote it as like I to the 14th, where we did a problem like that, where we added our exponents. I'm not going to do that this time, though. I like this 12, because that 12 is a multiple of 4. I to the 12th is just 1. So we get 1 times I squared, which is, I squared is negative 1. 1 times negative 1 is negative 1. So that one equals negative 1. All right. And last but not least, we've got 1 minus I times 1 plus I. Another distributing problem to do. 1 times 1 becomes 1. 1 times I is plus I. Negative I times 1 is negative I. And negative I times plus I is negative I squared. If I did that correctly, I think I did. 1. Yep, that looks good. Combining like terms, the i's cancel out. The plus I and the minus I go away. And this I squared is a negative 1. So it's a minus a negative 1, which equals 1 plus 1, which is 2. So that's going to be neither. Okay, yeah, that makes sense. Yeah, it's neither. I got worried for a second, but that should be good. Let's compare it to our answer key. Move the answer key down. So let's see, I to the 8th, I to the 12th times I squared, and the other two are neither. Very good. All right. Last one, number 18. This looks very similar. It's the same four expressions, I think, but the directions have changed. We have to indicate whether each number is real or non-real by writing in the appropriate column. Okay, I sort of wish I had saved the answers for the other ones, but whatever. We'll just go through it too pretty quickly. So I to the 8th, we know that's 1, so that's a real number. Just bring it down. Real. I'll move that up slightly. Okay. Now negative 1 times I to the third. Well, we don't need those parentheses there. That's negative 1 times I to the third is negative I. I will remember it this time and not do it the long way. And we get negative times negative just becomes positive. So we get positive I, which would be non-real. Non-real, because the I is still there. Now we've got I to the 12th times I squared. And like we said last time, I to the 12th is 1 times I squared is negative 1. So we get negative 1. No more I's means it's a real number. And last but not least, we've got 1 minus I times 1 plus I. I think that just came out to a 2, didn't it? Let me just go back and check and not waste our time. Yeah, that's a 2. And I guess that makes sense. We're multiplying two complex conjugates, where the only thing that's different in the complex numbers is one of the signs. So that's going to make the i's cancel out and give us a real number. Let's check the answer. And if we're right, we can end this video. I to the 8th, I to the 12th times I squared, and the complex conjugates, and negative 1 I to the third. So we're good. Hopefully this video was helpful. If you have any questions, let me know. Good luck studying for your quiz.